So, firstly, I like to say, Dr. Andres Plazas, that was a great daily space update. Thank you. That was a great, nice way to kind of transition over. That was a perfect setup there. And secondly, I want to apologize for my our stream last Wednesday. Um, it wasn't up to the caliber that I would have liked it to have been, and it was totally my fault. Um, Firstly, the audio settings for Joe were all messed up, but we fixed it. And so, with that said, I'm going to go ahead and give Joe another chance to just go ahead and reintroduce himself to you guys who don't know him.
Hey everybody, you can hear me today, right? Anyway, you're gonna hear my whole spiel again. I'm a developer for the Astronomical Society of the Pacific, currently working on Transient Tracker project, which will eventually, I believe, meld into the CosmoQuest project, but for now it's a separate entity and recently got put on the CosmoQuest project to transition our database management from Laravel to Django. Been having some fun with that. So sounds great. Looks like according to chat, and I suppose we can move on. I hear we doing some moon science today. I heard a rumor.
That is correct, Joe. We're doing some moon science today. And I mean, it's kind of a natural progression, right? We started off talking about Earth, and Earth's nearest neighbor is the moon. So it makes sense to, talk about the moon. So let's go ahead and just dive right into it. Um, I'm seeing here that there are a little issues probably with Joe's video. Hopefully that fixes itself. I mean, we've checked stuff and things seem to kind of go well, but it could be due to my computer having difficulties handling all of the resources it's trying to use right now. But hopefully, it gets better over time. All right. So with that said, let's go
I'll start
ahead.
doing the robot back here and see who.
Oh, that's a good point. Yeah, we should go ahead and start saying hi to people who are actually responding to us. Hey Guido. Hey Keeper of Maps. Hey Peter. Hi Nightbot. Hey Paranor. Hey Leary. And I know I saw Susie's name in there as well. So hello Susie. Welcome guys. Um,
Nightbot's what's causing the lag. We'll blame it on Nightbot.
yeah, I think it's definitely Nightbot. I think so. What's up, Uncle Bill Druin? All right, so we're talking about the moon, right? So of course, if you're going to talk about any particular topic, you want to have a nice little pretty picture of it. And the image that we're showing here on the first slide is an image taken, we'll credit it to NASA, and it's an image of the near side of the moon. We're going to get more into what that means, but it has a lot of features in it, and we're going to talk more about that stuff a little bit later. But if you're talking about a particular subject, what do you think is one of the first things you'd want to know about the moon, Joe?
Well, I heard a rumor that it was made of cheese, and I'd like to know if that was true or not.
How did you know? It's
That's
made
what
it's made
I
of
think. It
cheese,
was one of
guys.
the professors at the university that told me that. So
Well, not quite, not quite. So honestly, the theories behind how the moon was formed, at least the leading theory, is kind of like thoughts. Well, this particular image gives me the idea that hey, if you guys have ever seen the movie Armageddon, that's kind of what's going on right here. So sometime early in the formation of our solar system, and again, this is the current leading theory for how the moon was formed. Early in the formation of our solar system, the sun and the planets and stuff like that, we had essentially two protoplanets. One protoplanet being our Earth, and the other protoplanet being a Mars-sized object, and I believe it was named Theia, if I'm getting that name correct. But basically, Theia came along and it smashed into Earth, and this is a depiction of that interaction. And so it pretty much knocked away chunks of the Earth, and those chunks eventually formed what we now call the moon. Um, Very interesting idea of how the moon formed. And like I said, there's more than just this particular theory. There's actually two others. And this particular theory is called the I think it's the giant impact theory. The other two theories are one, the co-formation theory, which basically just states that the Earth was able to co-form along or form at the same time as the Moon formed, out of the same material within the orbit that corresponds to Earth's orbit. And then the other theory, the third theory, is known as the capture theory. And so with this particular one, Earth, of course, is formed, and some rogue piece of rock the size of our moon is coming along, and basically Earth gravitationally captures this big piece of rock. Now, of the three theories, it turns out to be that the giant impact theory just seems to have the less, problems as far as being able to prove its validity. It's compared to the other two theories mentioned. But I found this actually pretty interesting. This whole Armageddon situation going on here. But what do you think about it, Joe?
Well, I think that the capture theory is nearly impossible because that's the only way in my mind that that could take place is if the moon were to, at just barely faster than the speed of Earth, kind of creep up alongside of it and then just get slurped into that. And then, I'm sure the orbit was unstable for a while, but that just seems very unlikely to me.
I agree. Some of the papers that I've
And
read,
then the middle one, which one was the middle one that
the
they
middle one
formed?
was the co-formation theory that both the Earth and the Moon formed at the same time.
Hmm.
So the issue with theory number two, one of the major issues is that it's known that the Moon was formed at least 100 million years after the Earth was formed. And one of the other major issues with or another issue with theory number three is, like you were just saying, how exactly does the Earth accomplish this ability to kind of slow down, a massive object the size of the Moon, and then establish an orbit that exhibits the characteristics that we see today? And so, a lot of issues with all of that. At least my personal view on that is that there's a lot of issues with that, and I mean, you seem to share the same idea. Um, but yeah, let's see if the chat's saying something about this. So, is the impact location currently the Pacific, or is the Pacific just normal? And so, that's a great question. Honestly, in my readings, I didn't see anything that would indicate where exactly on the Earth the impact may have occurred. Hey Larry, if you have a link to that, that'd actually be pretty interesting to like read. So yeah, Larry brings up a very good point, right? Um, that the moon's isotopic composition is very similar to that of Earth's, and this actually causes some problems for the giant impact theory, because the thought is that various bodies within our solar system have different isotopic compositions. Um, and so, just to be sure that everyone's here on the same page, an isotope is basically um, different forms of the same type of atom. And the way in which these different forms differ is based off of the number of neutrons that are within the nucleus. So basically, you can have two atoms that have the same number of protons, which makes them essentially the same element, but the number of neutrons are different, which causes them to be different isotopes of the same element. But yeah, that was one of the major issues. Is that the idea is that various bodies in our solar system have different isotopic compositions, and so the idea is that Earth and Theia should have different isotopic compositions, and so you should be able to see the presence of these different isotopic compositions within the Moon. No problem, Larry. No problem at all. Um, but yeah, I couldn't. I didn't see anything that quite said that the impact corresponds to what we now know to be the Pacific Ocean. Um, but I'm definitely going to look for it and see if I can find anything on that. But also in recent research, though, some scientists believe that they found the evidence that the moon isn't all as similar as far as isotopes are concerned as the Earth. That there are actually some isotopes that are different and can give a little bit of validity to the giant impact theory. But I found this to be a very interesting story, and immediately when I saw this image, Armageddon came to mind, and I was thinking like, "Oops, Bruce Willis, didn't press the button in time." So,
Great movie, Liv Tyler.
indeed, let's play billiards with the early solar system. That's probably a good way of thinking about it, actually. What's that, Joe?
Planet billiards, where the sun is the corner pocket.
Yeah, the sun would eat up everything. Um, all right. So let's go ahead and move on to our next topic. Of course, I mean, you're talking about the moon. This is the early formation of the moon. One of the key things that we know about the moon, of course, are its various phases. Um, so, Joe, do you know about the phases of the moon?
Well, I know I could guess them. I don't know their order. I know we've got waxing and waning. I believe waxing is filling,
Yep.
and waning is shadow covering up.
Yep.
And then I know that there are names for the phases, but I couldn't tell you what those are.
Well, to make it easy,
and I know they cycle every 28 days. I do know
that. To make it, yes, that is exactly right. The phase cycle is roughly about 28 days. But to make it very easy, though, in this particular screen, or a slide, excuse me, at the very bottom, it actually goes through all the various phases of the moon. The interesting thing is that what it doesn't kind of show is when you'd expect to see the moon highest in the sky. So if you go across, if you look at the very bottom image, they kind of like outlines with the various phases of the moon. You kind of see the sun in the upper portion of the image, and then you kind of have like this kind of mini arc, and along the arc you have the moon, the Earth-Moon system. Well, it is showing, of course, the Earth rotating along its axis, as well as it orbiting around the sun. But it's also showing the moon, undergoing or moving throughout its phase cycle. And so, of course, when the moon is in between our sun and us, that is Earth, we have our new moon. Eventually, it'll move 90 degrees. In this case, towards the left. This will correspond to the first quarter. It'll move another 90 degrees. This corresponds to a full moon. This is, of course, is when the sun, the order is going to be the sun, Earth, and moon. Moving on from that, you get your last quarter when you move another 90 degrees, and then finally you come back to a new moon. You've made it a complete cycle. But what I want to note here is that you can actually use this image to kind of determine when the moon's going to be highest in the sky. If you could imagine a clock, and you were to put 12 o'clock noon at the position of where the new moon corresponds to, and you were to move around that clock, 12 o'clock noon, I think it then goes to is it 12, then to 3, then to 6, then to 9, and back to 12. You can kind of get an idea of when the moon's going to be highest in the sky. So when the moon is at when the moon is at the new moon phase, we'd expect it to be highest in the sky at 12 o'clock noon, and when the moon is at the full moon phase, we'd expect for it to be highest in the sky at midnight. And so I thought that was a pretty interesting thing to note with this image. But I really want to get to what's going on in these top two images here. There are actually some quick animations. I hope everyone likes animations because I sure do. And so I'm going to try my best to kind of get them to play simultaneously. Ah, I'm failing. I got this to work last night. Ah, okay. It's not playing simultaneously. I really want it to play simultaneously. And the reason why I want this is because what we're looking at in these two animations, and these aren't actually animations. This is actually real data of the moon. What we're looking at are essentially two different perspectives of the moon, but roughly at the same time. The perspectives being for the left image, we're looking at the moon in the northern hemisphere, and the other perspective being looking at the moon from the southern hemisphere. And what you basically notice, and it's kind of difficult to notice when the two movies are not playing together. Let's do this, because I'm going to get these two to play together. Um, let's see. There we go. That's a little bit better. Okay. So now that they're playing together, the idea is that no matter where you're at on Earth, the phase of the moon will be the same. However, what you physically will see in the sky may be different, depending on whether you're in the northern or southern hemisphere. And so that's one key thing that we're seeing in these images. Joe, can you see anything else kind of weird happening with these movie clips?
Uh, I mean, the shadows seem to be approaching from the opposite sides, meaning that if it's waxing in the north, it's got to be waning in the south. It's in my head. I don't know if that's correct or not, but
No, that is kind of and I completely get what you're saying, but actually, because whether you're in the southern hemisphere, or the northern hemisphere, the actual phase is the same. So if the moon's in the process of waxing, it's the shadow is leaving. But if the moon is in the process of waning, then the shadow is growing bigger. Um, so you're actually going to end up getting the exact same phase. It's just that you're going to get a mirror image of it.
okay.
But another key thing to note is that look at how the moon appears to be moving, away from us and towards us. And not just that, it kind of looks like it's doing this whole like little wobble thing as well. Well, the reason why it's doing this is due to the fact that the moon's orbit around the Earth is not perfectly circular. It has something known as eccentricity to it, an eccentricity value greater than zero. And this basically means that the orbit is not perfectly circular and that it's a little what's the word I'm looking for? Elliptical. Um, and this actually is a very important thing to know because of the fact that sunlight always hits 50% of any particular surface. And as I should tell you guys now, the moon and the Earth are both locked. Exhibit a property known as tidal locking. And what tidal locking is that, or what the effect of tidal locking is that we'll always see the same half of the moon as it orbits around the Earth. In other words, this image, the picture that we're seeing, whether you're in the northern hemisphere or the southern hemisphere, will always be the same. We're always seeing the near side of the moon, and we never see what's known as the far side, which is the other half of the moon that we never see. But this particular this particular phenomena that we're kind of seeing here with the whole moon moving back and forth and doing this wobble is known as libration. And because of this effect, there are times when we see 50% of the moon, and there's times when we see a little bit more, as much as up to almost 60% of the moon. And this is all due to the fact that the moon doesn't have a perfectly circular orbit around the Earth. And so that's actually pretty cool knowledge to know about the moon. So my next question to you, Joe, is what are your favorite events or naturally occurring events that are related to the moon? Do you have any?
Yeah, I like it best when it's full because that's when it makes people crazy. I'm just kidding.
Oh man.
I'm just kidding. Actually, I was poking a little fun at people that perpetuate that nonsense. But no, I mean, eclipses are obviously the big show. I'd say that the solars are more fun than the lunars, but I missed my opportunity a few months back to get into a totality zone. I stayed just a few miles to the south where I was supposed to get 99.3% coverage.
I see.
And unfortunately, even that 0.7% still looks like a full blown sun. There's not much to look at unless you're using one of those little tools, the little pinhole tools.
You
So
are so
next time,
correct.
get into totality.
What was that?
Next time, I'll get into totality. I think when let's
I think it's
see,
I think it's 2021.
2021.
I believe so. So
Next time,
I'm pretty sure
big
someone can
one.
verify that. Is that right,
I'll be
Gus?
ready for that one.
Is that right, chat? Is it? Oh, it's 2024. Thank you, Keeper of Maps. Did someone bring up something related to werewolves?
Oh yeah, man, I forgot to tell you about the werewolf one.
Oh man. Okay. So I'm happy you brought up, the fact that of course, almost everybody knows about, you know, eclipses, right? They're very important. Um, I've even heard back in the days, that I think it was a story about, there may have been someone being accused of being, doing witchcraft, getting ready to be hung, and like at that very moment, a total solar eclipse occurred or something like that. I think it's a story. I don't know if it's any like validity to it, but eclipses are, especially given that I just, saw my very first. And I'm sorry, I'm not trying to rub anything in here, Joe, but I saw my very first solar eclipse, this past year, and it's a life changing event in my personal opinion. Um, so what we're gonna now talk about, of course, is solar eclipses and also lunar eclipses as well. Um, so the Earth, of course, we know that the Earth revolves around the sun, and it revolves around the sun in a particular plane known as the ecliptic. Well, the Moon revolves around the Earth, but the plane in which the Moon revolves around the Earth does not perfectly overlap the plane in which the Earth revolves around the Sun. In fact, there's actually a 5-degree offset, but well, I think it's about 5-degree offset between the two. And so, in order for you to get particular types of eclipses, it depends on the conditions of the eclipse. That is, if the Earth, Moon, Sun system are perfectly aligned or just slightly aligned. And so there's actually three types of solar eclipses. There are the annular eclipses, there are the partial eclipses, and there are the total eclipses. And so the difference between the three are that with a total eclipse, you get perfect overlap between the Earth, Moon, Sun system are perfectly aligned, and the Moon is just in the right position to the point where it totally blocks out all the light from the Sun. With your partial eclipses, you don't get perfect overlap. You get enough overlap to the point where the Moon will cover a part of the solar disk and block out some of the light, but definitely not a situation of where you could just look up at the sky and look towards the sun and be able to look at the sun without any sort of special eye protection that Joe was bringing up earlier. And then there's of course the annular eclipses. Now these are very special. They're kind of like total eclipses. So the Earth, Sun, and Moon are like perfectly aligned. But the problem is this though. An annular eclipse is kind of like what we're seeing here in this particular image, where we're looking from the perspective of Earth, we're looking up towards the sun, and we see that there's something blocking the sun, aka the moon, but there's still light coming out from around the sides of this dark shadow. And this is due to the fact that, even as I stated earlier, the moon's physical position relative to Earth changes. I actually did not state this, but it changes because of the fact that the moon's orbit is not perfectly circular. It's elliptical. So every now and then, the radius between the Earth and the moon, well, not every now and then, but the radius between the Earth and the moon changes as a function of time. And so with annular eclipses, the situation just so happens to turn out to be that Earth, Moon, and Sun are lined up, whereas you have the Sun, Earth, and Moon in between. But the Moon is far enough back away from the Earth, such that you can still see the outer portions of the solar disk. And then there's the other type of eclipse, and as Joe stated, these particular eclipses, aren't that interesting, but nevertheless they occur. Um, there are the lunar eclipses. And in this particular situation, you have you have the sun, you have the earth, and you have the moon, where the moon occults or basically blocks sunlight, and the shadow that the earth casts is such that that shadow falls on the lunar surface. Before we move on to talking about our next particular subtopic of talking about the moon, I want to state that in the case of solar eclipses, they occur when the moon is in the Matt, don't get this wrong, but the new moon phase, and lunar eclipses occur when the moon is in the full moon phase. So, moving on to our next topic, and let me quickly look at the comments because I'm just talking away and I'm not actually looking at comments. But yeah, lunar eclipses are cool. I don't want to downplay the lunar eclipses, but the solar eclipses though, especially total solar eclipses, are just. Wait a second. I'm seeing some comments here about. I don't think that is correct. So let me scroll up and see what's going on. The human eye doesn't see intensity of light. Yes, so the safe disaster is correct. Human eyes see light along in a logarithmic scale. Um, in astronomy, we call that logarithmic scale magnitude. Yeah, that is so crazy, Hanny. That is so right. It got extremely cool during the most recent total solar eclipse. Um, I mean, it was already cloudy where we were at. In fact, part of the total eclipse we couldn't see because of the fact that the clouds got in the way, but we were able to see enough of it. But it got crazy cool, and not just that, but if I can remember correctly, there were actually animals in the sky that typically aren't in the sky during the day. I think there were some bats or something like that, and it was crazy. Oh, keeper of maps, I'm jealous. No clouds. There were plenty of clouds where we were at. I almost thought I was going to miss it all. But yeah, moving on to the next topic in our discussion. So, Joe, I mean, I'm just gonna throw an image at you, and I want you to tell me what you think is wrong with this image. Here we go.
I'm good at this game. I remember it takes the
Oh yeah, there's a delay.
few seconds to update before I see it. So I still haven't seen your surprise image.
Sorry.
There it is. Uh, that's probably where a telescope's at.
Not that. Something else.
St. Michael's Mount.
It's the same location on the Earth, but there's something different about these images.
Oh well, the roadway is gone on the bottom one. That appears to have been in the top one. So
Yes.
some sort of between those two islands.
So, do you think you know what's going on here?
Yeah, I think when it goes away, the moon is snatching all the water up into this area
That is exactly right.
tidal power, and then I think the moon's on the other side of the planet when the path reappears.
Well, the thing about it, and this is actually quite interesting, is that this
Uh,
effect that's happening with this particular island, and this is known as an actual tidal island. But the effect that's going on happens on time scales of hours, actually. Um, and I'm pretty sure that someone here probably knows about St. Michael's Mount. But I was looking at the site, and apparently that road is only can only be used over the course of a few hours. Otherwise, you might get swept away by the tide, which is kind of crazy. But another thing that I want to talk about, of course, and again, and I know that the topic is the moon, but typically, whenever you're talking about the moon, I mean, you got to talk about the sun as well. But this is another Earth, Moon, Sun, system effect, and it's the fact that we have tides, and these tides are brought about due to the gravitational interactions between the moon on the Earth and the sun on the Earth, but specifically the Earth's waterways. So actually, tides occur with all waters on Earth, and this is due to the fact that there's going to be like a differential force over the length of or over the depth of that particular um, waterway, whatever it may be, that's caused by the moon and the sun. And so, moving on to our next slide, we have here another animation that kind of goes more into it gives it kind of gives a better story of kind of what's going on with these tides. So I'm going to go ahead and play the animation, and what we're seeing here is, of course, on the far right hand side of the animation, we have sunlight, which means the sun is off somewhere towards the right of our Earth Moon system. We have the Earth, and in itself, it's kind of like stationary right there. And then revolving around the Earth, we have the moon. And of course, none of this is to scale. This is all been done by a computer. But basically, we see that as the moon travels throughout its phase cycle, we kind of see some really cool changes to the blue region within the animation, where the blue region corresponds to essentially the oceans that are on the Earth's surface. And so the key things I want to note are that when the when the Earth, Moon, and Sun are on an apparent, line, and they're not really perfectly lined up again because remember that the Moon's orbit around the Earth and that plane is slightly offset between the Earth's orbit around the Sun, the plane that makes. And so the key things is this: when the Moon is in the now coming up on the new Moon phase, the waters on the Earth are at high tide. However, when the moon goes back around another 180 degrees and is at the full moon phase, again we kind of see this whole high tide situation. But in the cases of where the moon is actually um, offset perpendicularly to the line between the Earth and the Sun, we kind of get tides at their lowest. And so this is actually a really cool animation showing what's going on here and showing how the Earth or how the moon and the sun affect the tides here on Earth. And there's also a few other cool things going on here that you can kind of see. You see that only one half of the oh well, one, you see that with the moon, as far as sunlight's concerned, it's only illuminating only half of the surface area of the moon, as well as on the Earth. Um, and then there's also some other information here within this animation, but we're not going to talk too much about that because the key point is that the sun and the moon. affect the waterway or affect the oceans on the Earth, and this is how they affect it. All right. With all of this said, it's time to now, of course, move on to talk about what other features that we know about the moon. And so moving along, and hopefully everything goes okay with transitioning between the slides here. There we go. All right, so this is actually an image that was taken sometime during I believe it was the mid 1800s, by a French photographer. And this image, of course, was due to the fact that we had technological advances in optics. So prior to the early 1600s, our ability to be able to know what features on the moon was all based off of the human eye. And so apparently there were some people that were able to actually make out, more broader features on the moon. But Joe, if you were to look up at the moon, on a perfectly clear night, just look up at the full moon, do you have the ability to like make out certain features on the moon, even if they're just like general
Oh, for
features?
sure. Yeah, you can definitely see some cratering and large areas of just flat, what appears to be flat, smooth areas as well. I know they're not because can't quite make out the details of all the cratering
Mm-hmm.
with just the naked eye from Earth, but you can definitely see the larger and more prominent ones.
Indeed, indeed. Well, I mean, my eyes aren't that great, aren't that great actually. Um, I recall during one of I was TAing for a observational astronomy lab course, and it was the night of observing. I mean, we were going out to observe the moon, and the professor of the course was like, "Well, you should be able to see certain features on the moon," and I was just looking up. And note, I'm TAing the course, and I know the general knowledge, of course, but I've never actually, really, really paid, tried to look at the moon with my naked eye, in great detail at least. And I'm looking up, and I'm just like, nope, nope, my eyes just can't do it. I'm seeing a white ball up there right now. I couldn't make out any features. All the
White ball,
others,
zero details.
huh?
White ball, zero details.
Exactly. I felt so bad because everyone else was like, all the students are like, yeah, we can see this and that. And I'm like, yeah, I can't see that. My eyes just aren't doing it. but but apparently, of course, before the 1600s or early 1600s, there were people who were able to actually make out, fairly, good maps at least of some of the more general, broader features on the lunar surface, at least on the near side of the lunar surface. However, I believe it was in 1609, there was the invention of the telescope that's been credited to Galileo. And so, of course, now that we have the telescope, we could just point it up and, look at various, astronomical objects. And of course, it would make perfect sense to aim the telescope at the moon. And, for the first time, we're able to see these features. I mean, in much greater detail, at least, see these features on the lunar surface and note that, oh man, the surface of the moon is not flat. There's mountains and stuff like that. Um, and so going back to this image here, this we're basically seeing within here a ton of features. As Joe already noted, you can see craters in this image. You can see these really dark regions, which are known as I believe the plural form is Maria. And basically, there are regions on the lunar surface that contain um, there are basaltic plains on the lunar surface that are due to volcanic activity very, very long ago in the history of the moon. And so it's actually a really cool image. Um, and I was kind of not too shocked actually because taking into consideration the telescope was discovered or was invented in early 1600s, and this image was taken in the mid 1800s. Okay, cool. This is a really nice image of the moon. However, that was the first big leap that we had as far as being able to observe the moon. Can you think of the next big leap we had with being able to observe the moon, Joe?
From Galileo's scope?
From Galileo's scope.
Let's see. No, because the story from there goes that he found the four big moons of Jupiter. Or was it
Hmm.
Saturn? It was Jupiter. Anyway, that I just remember him finding the Galilean moons, and then it's a blur from there. So no, I couldn't tell you what
So,
helped more with the.
so here's a question: do we know what the far side of the moon looks like?
We do.
How?
That's from spacecraft orbiting and landing on the moon and taking images.
That is correct. So space exploration, right? That's the next big step, right? The moon, of course, is our
That was
closest.
a long time.
Huh?
That was a long time later.
Yes,
That was
it was definitely a
later.
long time later. Well, wait, yeah, it was definitely a long time later. But I mean, nevertheless, it was the next major step, right? You know, thanks to the Cold War, essentially, we made I want to say mankind made a great effort to get to space. And of course, because the moon is the nearest object in space to us, let's go ahead, make that effort and get to the moon. And that's exactly what we did. And so, what I'm going to do now, what I'm going to do now is move on to my very last slide here. And of course, it's directing me to um, go to an online website. So let's go ahead and change the scene up here and see what we can find here. Let's see. Mm, 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 mm.
And the moon's so dope, it's got its own website.
It got its own website.
I
That's
don't even
correct.
have my own website.
Let's see. Here we go. Oops. Is that it? There we go. All right. So, if I'm not mistaken, I think this was the late 1950s. Um, Russia, well, many people can look at it as Russia beat the U.S. to making it to space. But who cares about at least from my perspective, who cares about what particular country made it to space? Mankind made it to space. It was a tremendous feat, and I'm pretty sure it was being fueled by reasons that were not just to help us better understand the moon itself, but nevertheless, we've made it to outer space, and now we can begin to kind of get images, of course, of what the moon looks like. And that was the late 1950s. Now during the 1960s, though, um, the U.S. was finally able to make it to space, and took a little bit of a step further for mankind, and that is we can now actually land on the moon and do all types of cool research now that we actually have physical access to the moon. And so this particular site actually is a very useful tool if you want to be able to just kind of like, increase your general knowledge of the moon. And so,
Yeah, we're live music, huh?
what was that?
I was answering somebody in chat.
Ah, okay. And so what we're kind of seeing here is, and I believe, if I'm not mistaken, this is definitely an image of the moon, um, and I think it might just be wholly the. Let me make sure. I think it might just be the near side of the moon, because if I'm not mistaken, on the far side of the moon, you have less Maria, but we kind of see a few key features here, and it indicates what the features are along the left hand side of the page. Um, the human landing sites, that is the primarily the Apollo missions, robotic landing sites, as well as various geographic features on the surface of the moon. Um, and if I'm not mistaken, I think it was the Apollo 11 mission that was the first mission in which man was actually able to take, take their first steps on the moon. I could be wrong there. Someone would have to verify that, but I think it was the Apollo 11 mission, which has kind of put us right here on the lunar surface. But there's also various other tools, and I'm going to go to some of these other tools that we have here. Primarily, this particular one. All right, boom. That's actually pretty cool. And so, we have information about the interior of our moon. And the reason why we have information about the interior of our moon is due to one of the Apollo missions and them taking a seismograph to the surface of the moon and doing seismic readings. And so with those seismic readings, we were able to get a general picture of what our moon looks like. And if you look at it, it kind of looks like the interior of the Earth, right? Like we discussed. Well, not exactly like it, but kind of like it as far as its composition, like we discussed in the previous stream. The moon, it has an inner and outer core, where I believe the inner core is solid, the outer core is liquid. Then we move on to having a mantle, and then we finally have that the outermost layer being the crust. And so um, and also another key feature they're showing here is that there are moonquakes. Now, one of the key things that I end up running across in trying to find out a little bit more information about the moon is that the moon does not have plate tectonics, from my understanding, unlike here on Earth. I can't go into great detail as to what that scientifically means for the moon, with it not having plate tectonics, but it does have quakes apparently. So that's interesting. I mean, with my idea, the quakes on Earth are due to plate tectonics. So I'd need to read up a little bit more to determine exactly what causes these moonquakes. But there's also some other key information here on the page. Starting at the bottom left of the page, we kind of see this clock that states orbiting now LRO. And so what this means is, or what this stands for, is the fact that besides, of course, sending rockets into space and sending man, into space and being able to land on the moon, we've also accomplished the ability to put satellites into space. In particular, we put this one particular satellite with the acronym LRO, which stands for Lunar Reconnaissance Orbiter, which now currently orbits the moon and actively takes images of the moon. And this is actually a perfect chance for me to kind of throw in there. If you ever get the chance, because me and Joe work for CosmoQuest, if you ever get the chance, stop by CosmoQuest, check us out, and see what sort of citizen science projects we offer. Pretty fun. And so, yeah, if you get the chance, stop by. But basically what that particular clock is letting us know is, if I'm not mistaken, how long the Lunar Reconnaissance Orbiter satellite has been orbiting the moon. And that's a pretty long time. Next up would be the next full moon. I mean, this is basically information about that particular phase of the moon. And then from there, you go on to seeing number of humans who have visited the moon. 24 people. It's been that many. Wow. Okay. That's impressive. And then lastly, it shows what the current phase of the moon, what phase we're currently in with the moon. There are other resources on this website. If you ever want to know about the moon, this is a great place to go. If you ever get the chance. And for the most part, that's pretty much the discussion. And I mean, I open up the chat for questions to me and Joe. I'm pretty sure I've been missing some questions, but
Yeah, music. Hound 31 had a good one about the moon.
let's see. Okay, so Music Hound 31. Intense core heat could cause quakes. Okay. I should note, guys, that my primary background is in high energy astroparticle physics. Um, so, I mean, I won't know everything there is to know. Now, if this is your particular area of study, then by all means enlighten us. Yes, the moon is tidally locked with the Earth. That is correct.
He's asking why. He's not asking if it is. Someone else already answered him yes too, and he's not getting the answer to his question.
Okay. So the tidal locking of the moon and the Earth would have to deal with how they formed. And this is live, Music Hound. Yes. And more than likely, the tidal locking is due to conservation of angular momentum and energy for our system, or for the solar system in general. That's more than likely the short answer for why they're tidally locked. So is the interior of the moon still hot? Well, this depiction of the moon would indicate that it is. As to how hot it is, I don't know. And so Keeper of Maps makes a good statement here that given that there are no tectonics on the moon, that it's probably not that hot inside. Thanks, Keeper of Maps. And so Keeper of Maps also brings up the fact that there are no convective currents inside the moon. And so for those of us who probably don't know what convective currents are, so convection is one of the three modes of energy transport. One of them being radiation, the other one being conduction. In the case of convection, typically you have the flow of bulk mass, and this bulk mass becomes buoyant in becomes buoyant due to the differences in density of that mass and in the surrounding medium, which allows it to rise in height within that medium, and eventually it will get to the point where it's no longer buoyant and it will dump its energy at that particular new height. And so that's the process of convection. Hey guys, Keeper of Maps has actually put some good information out about the internal structure of the moon here. Thank you, Keeper of Maps. So Larry asks, where is this? Oh, where is this cutaway view? Sorry. Um, so it's located at moon.nasa.gov, and to be able to access it, you'd go to the right hand side of the page, and you'd click on the icon entitled Core. It's underneath the Tools section. Oh wait, Big J beat me to it. Thanks, thanks, Joe. Oh, Hanny, that was perfect. Like boiling water. That's a perfect example of convection. So have they sent a probe to detect the interior? So my understanding is that during one of the Apollo missions, they had a seismograph and they were able to actually take measurements of the seismic activity within the interior of the moon, and they used that data to be able to kind of get an idea of what the internal structure looks like. So what keeps the combined gravitational pull of bodies Earth? Oh, well, that would have to be due to centrifugal forces. So the moon would have to maintain a specific velocity going around the center of the Earth to be able to fight against it falling into the Earth's surface. In fact, if I'm not mistaken, the moon is actually in the process of slowly drifting away from the Earth, and I think that rate is, I think it's about, it might be about an inch a year, I think. So that what that ultimately means, though, is that eventually we will no longer get total solar eclipses because the moon will have moved far away from the Earth to the point where it's not possible. So at best, we'd be able to get annual eclipses and partial eclipses. But of course, I won't be around for that. I mean, this is going to happen like in on the order, I believe of like millions, millions of millions. Well, not millions of millions, but probably tens of millions of years. I have to look it back up again. Good point, Noel. Honestly, I don't know what the I don't know what the what is it? The temperature profile for the Earth is. Well, the interior temperature profile of the Earth is. In our stream on Wednesday, we kind of looked at what the temperature profile of the Earth is above the Earth's surface, as the temperature changes as a function of altitude above the Earth's surface. But I don't know exactly what the temperature profile of Earth is. That might be a little bit interesting to look into, actually. Yeah, good point, Peter, about having you got to pay for everything nowadays. Which is the reason why earlier during Andres stream for the daily news update, there's the archive and all this information, all this science out there is available for free if you ever want to learn about something that's happening in science. The archive is a great place to check out. Yeah, geothermal heating. I mean, aren't like hot springs due to heat coming up from the interior of the Earth? Yes, exactly what Larry stated about the similarities between the moon's interior and the Earth's interior about the core. How it has a solid core and a liquid outer core. Wait a second. A few scientists, when landing on the moon, said when they landed, it sounded like a giant gong. I'm assuming they heard this sound while they were the um within the spacecraft, because within the spacecraft the density is high enough for sound to be able to propagate. But then again, I mean, whenever there is any sort of like collision between things, um, if the collision has enough energy associated with it, that would produce a shock wave. and whatever the shock wave interacts with, you know, it could produce sounds within that particular material. So, but yeah, I don't know anything about it's sounding like a gong, but that's actually quite interesting to know. It's just crazy that. Good points. Good points, Big J. I'm sure I am so far behind the chat. I'm trying to catch up and read all the comments, guys. I heard that if the moon travels around its planet faster than the planet's rotation, it will get closer. Um. Well, if the moon were to travel faster around the planet's rotation, it will get closer. So if the moon were to change velocity such that its velocity increases, it should actually begin to get. It should be able to break away from Earth's gravitational attraction to it. It should actually get farther away if you make it faster and faster, because then its centripetal force is higher. I mean, I think another way of thinking about it is if you put energy into a natural satellite, where that energy is in the form of kinetic energy, it should be able to be able to break away from its host planet's gravitational attraction on it. Thank you, Peter. Did I get that all messed up? Did I say that wrong earlier, Peter? So daily space, right? Andres did daily space earlier. Oh wow, the moon is the second densest satellite in the solar system. After I did not know that. Eventually we're going to get to talking about other objects in our solar system. That's actually pretty cool. If I'm not mistaken, I think Io is a moon of Jupiter. I could be wrong though. Um, that's an interesting question, Hanny. Would building on the moon be easier or more dangerous because of lower gravity? Um, hmm. I don't see any reason besides the fact that the moon doesn't have a thick atmosphere. It has an exosphere. Um, I think that the main danger, to any sort of builder, will be the fact that they're working in essentially atmosphereless. I mean, if that's even a word, but they're working without an atmosphere. That would be the thing that would concern me. And then there's also the fact that there's less gravity. So if you throw something, you can end up, if it has enough velocity to it, it can fly a great distance away from you, which would probably make it more difficult to build. But as far as, I mean, danger is concerned, I would be more concerned with the fact that there's no atmosphere. You'd have to rely on a suit. If something happens to the suit, that means that something can happen to you. But easier, um, less gravity, so the weight of things aren't going to be the same.
Astronomy cast is up in 20 minutes, Matt.
Okay, so Joe's letting me know that we need to go ahead and wrap this up, guys. I was actually enjoying going through your comments here, and I can clearly see that I am so far behind. Um, but guys, thank you guys for joining today. Um, me and Joe enjoyed, answering your questions and presenting this information to you. We're going to be back next Wednesday after another episode of The Daily Space with either Pamela or Andres. And we look forward to it. We'll see you guys then. All right. Bye, guys.